SMART is committed to ensuring that participation in the development of standards is unrestricted and the process for their adoption is transparent, and the standards that are developed do not favour any particular provider and are open, non-binding and accessible to all. Please take note of our anti-trust code of conduct. And with that, I would like to hand over to our first presentation from over to you.
Can we start now?
Yes.
Okay, our friends of openBIM, good morning. We have a big team came to Montreal, and we also have the online team from Hong Kong. I'm representing the property developer and the owner of the project building, the Henderson. We also have our close partner here, including our main constructor, our design architect, project architect, and also a number of BIM consultants. And the building is at the premium locations in Hong Kong. Is in the intersections between the Central Business District and also the government headquarters. Up to this moment, still the most expensive land in the world in terms of meter square of gross floor area. The Henderson is a super grade A office building and is now undergoing construction stage and will be the new icons of Hong Kong. And people-centric and sustainability are the project objective. And we bring many high-tech infrastructures and many innovations, and also we have a science-based design for our building. And our ultimate goal is to create a workplace for the future that will benefit not just our tenants and also our tenants' individual staff and also the people and the community. And the project has already widely recognized by many top-tier international, national, and local levels of award, and also accreditations at highest rating, including just early this year we got the buildingSMART Hong Kong, openBIM, openGIS brand award, and also some others government-initiated BIM award and Autodesk award already. And over the past few years, our project team has been conducting many, knowledge sharing and experience technical talk to the industry peers and also the practitioners as a matter of experience sharing to the industry. And we have a strong and big BIM team at the beginning of the project. The leading BIM consultant was responsible to set up the BIM implementation plan, including openBIM and also a common data platform. The consultant also has to take care of all the sub-consultant focus on different part of BIM. Just like we have one consultant specializing in DFMA, so they work together with our design architect, Sarah Hadi is here, and for the sophisticated double curve curtain wall. We also have our MEP specialist consultant taking care of MEP design and MEP BIM. We actually carry forward the 3D and 4D model and also all the building access data and information going to the construction stage. And our main constructor, Hiping, is responsible to take care of the implementation of openBIM and also get together all the sub-consultants, subcontractors, and also suppliers to have an integrated BIM model. And the model is not going to be end at the construction. Will be carried forward and to be integrated with the digital facility management portal. Will be form part of digital twin. And because I just mentioned we got so many sophisticated systems, so our digital twin is going to link up with the Hong Kong first GSG partnership program. Because through the system, we can get all the building operation data and even users ESG behavior data. We can get those in our analytics system. So that is a loyalty program for the future tenants and also their tenants, individual staff, and also our property management. So that's the end of my introduction. Thank you.
Hello, I'm from the architect. Well, the architectural approach for the Henderson is in response to the site conditions. Its organic and smooth language comes to balance and suit the prominent neighbors in the area. with a monolithic object without even one sharp corner. The tower is elevated. Sorry. The tower is elevated off the ground to plug into the network of pedestrian bridges and to create what we call a green oasis at the entrance area connected to the adjacent park. To tackle the tight footprint and the notoriously high wind loads of Hong Kong, we had to adopt new technology in the industry. So it's heat strengthened, doubly curved, large-scale unitized glazed system. This comes, however, with a whole new set of restraints which not be able to manage without the early and holistic adoption of parametric 3D modeling tools. The project massing and facade system were fully developed in digital project from early design stage, which allowed us quite precise control of the geometry and curvature up to the manufacturer limits. We could do a real-time dimensional tracking and control and adaptive rationalization and quickly response to any cost evaluation without the need of any design compromise. IFC format exchange allowed us to work in tight coordination with the other trades, allowing us to design accurately on support live in 3D. Together with our sub-consultants, we developed the whole facade system in LOB 350 for tender to prove its workability and to allow the bidders to accurately assess the complexity of the project. This coordination is ongoing in design stage as well. We are currently reviewing and approving well-coordinated shop drawings in LOB 400, and we are still able to react on any ongoing challenges and changes.
From design stage, building information can be developed with highest integrity to facilitate the direct drawing generation and the detailed 3D geometry for future representation use. We hope to maintain the single source of truth with multi-dimensional collaboration, which not only enhance the productivity, but also for better project management. And in this project, we comprehensively adopt the IFC and the BCF into our daily coordination. The team is very confident with the exchange schema, which is governed by the buildingSMART with the IBM. Before the project start, our team manager will start with the definition, with the model view definition. That is to design what elements to be used, what to be included, and the exchange format as well. And then it will become our project standard, followed by all the project members. This progress recur, and the information model will finally become an access information model. The maintenance related information will be extracted from the COVID light and then to be imported in the FM portal. And here you can see that the project team has adopted 5 different native model tools ranging from different disciplines. Since the project team is already being educated and guided with the openBIM strategy at the very beginning by our team manager, so the team can define a suitable software being used at different stages towards an openBIM approach, and the selected native software must have to support the information exchange of IFC version IFC2 version 3. Then each individual IFC models can be shared and integrated into the CDE. All these collaboration to support issue logging and exchange through the BCF XML. In this project, we transfer all the issue logs into the BIM chart via the BCF XML. And openBIM allows all the project members to participate regardless of the software they use. For the overall project, we have also adopted the rules as stated in ISO 19650. For the work in progress status, although the design tools like Reaper, Tekla, or Rhino, their functionality are very different. But IFC allows us to better collaborate across this software and reach them up to the shared status. And BCF allows the exchange of information through multi-collaboration platforms such as Solidly, Dialers, or Nove. And Triple Connect here acts as a CDE, keeps the integrity of our collaboration process, as well as the interchanging platform to download all the latest information for our further BIM analysis use. For example, the energy analysis or for the rendering purpose. From share to publish status, the IFC and ECM facilitate common language to consolidate all the information from design information delivery to contractor formal document submission. And the published documents will be archived into the client's DMS, which acts as their organization CDE. This hybrid CDE approach allows users to utilize their information at the right status from the design office to the frontline workers that may be miles away. Quantity takeoff. It has been performed in native form and also on the CDE platform. For example, the quantity of the structure elements can be extracted from the TECLA, and then the quantity from the entity elements can be extracted from the Wizard, but it can also be extracted from the CDE. The openBIM allows us to cross-check with these two methods and ensure a more accurate estimation to be conducted. For the procurement stage, the quantity selection in procurement is very critical to bridge up our design effort towards the construction. And luckily, our client has a strong end in mind since the design stage, including the full support of the design development, and all the members has to contribute within the CDE. This helps to prepare and develop the digital twin at the later stage, and the responsibility of the BIM input with openBIM collaboration are explicitly written in the procurement terms. Therefore, our main contractor will depend together with the leading subcontractor deemed to be equipped with sufficient BIM maturity. These are the basis, and to ensure a smooth digital information to hand over to the construction stage. And I will pass over to my BIM manager to continue with the construction stage.
For construction, due to time limitation, our site tackle the top-down construction. But having been become the major part in our construction because it's transferred to primary loading transfer for the whole tower. At first, it is designed as in situ concrete, but supported by the design model, our engineering team proposed to use steel structure because some of the work could be transferred off-site. And the counter proposed model is also interoperable to other platforms for reviewing and provide seamless communication. As a result, our construction time for the cabin beam reduced around 20%, with the equivalent loading performance, but better, but easier workmanship and higher construction quality. Our next showcase is with the collaboration of interfacing between the steel structure and reinforcement bar. We have the typical detail for the rebar as normal patches, but in our projects, we have steel structure in each floor. We took use of the fabricated steel model in RC format to review with our rebar model in the CDE platform. Our engineering team found that some of the rebar person with the steel structure, and then we design the detail before construction. This reduced us a lot of abortive work on site during installation. Next is about headroom. The glacier headroom is very important to our Grade A office in an essential business district. And in our team workshop, we frequently work with our subcontractors to review the design to strike the balance between our buildability issue and maximize personal space. IFC model allow us to IFC openBIM consolidate models from all parties that consolidate our regular discussion and avoid remodeling and discrepancy. As a result, you can see that most of the MVP routing to fit into the fortress. There are 8 outcomes we could put in our project, and this matrix is proven that we are achieving the 4 openBIM key objectives. They are the interoperability, traceability, controllability, and sustainability. And this also leading us to have our 7 innovative BIM users. The first one is automation. Apart from the API and the Dynamo application, the IFC model allows us to have more options to choose and to fulfill our statutory rule tracking, such as we use Solabit for our staircase tracking And our consultant team and subcontractor do a lot of energy analysis to fulfill the future occupation quality. They can embed their knowledge into the model, and the model is also interoperable between the design and the analytic software. Based on the federated IFC model, we success to modelize around 70% irregular facade cap, which reduces around 30% construction time. And our model is also converted to 3D printing machine. And the 3D printing model is allow us to have more interaction with our project team to create a better insight into the project. And to achieve a smooth driving path, our model is converted into vehicle sweep path analysis to provide a smooth and vehicle movement.
Okay, thank you, Kane. In the Henderson, we adopted 3D laser scanning to obtain the precise data for steel construction. This precision comparison, to begin the precision comparison, we have to collect the point cloud model along with the virtual construction model by IFC format and importing them into the site zone. This comparison is essential in our projects, because the steel construction is highly determine the future construction assemble tolerance and the MVP clearance. To enable digital twin as the model for FM users, we initiate dynamic BIM collaboration from office to frontline. To achieve this, we provide in-house workshop for our site workers to adopt AR softwares. Before the MVP installation begins, our building service coordinator frequently makes use of this function to plan out the MVP installation with the site workers. From their feedbacks, they find it really handy, especially the instant overlay with the as-built environment, so they can verify the information they're looking for. Well, we also make use of this function to verify as planned BIM model against the assembled environment to make sure everything is going as planned. The impressive outcome of the immersive VR experience is the success evidence of the openBIM integration. To achieve this realistic sense, the stakeholders have to integrate the model through openBIM collaboration, which allow us to visualizing the future of the Henderson before it is built. To enhancing it furthermore, we can implement BIM case in the future, which allows stakeholders to collaborate seamlessly. In the beginning of the project, we find it very difficult to obtain the site surrounding area information. So to tackle this pain point, we take the initiative to learn GIS to see how can it help our projects. This aspiration is actually come from buildingSMART Hong Kong chapter. They have been working hard to promoting openBIM and openGIS integration in Hong Kong. We're also working along with them with the aligned vision. Thank you. And I will pass it back to CC for conclusion.
Okay, so you have been hearing a lot of our BIM strategy so far, but adopting BIM in the project is not easy. So we would like to share with you guys some of our difficulties during the collaboration by using BIM. At first, we observed some data loss or mistranslation across different software. A typical example related to the curvature of an element of a native facade model, which converts to step format. But the geometry of the curve has been transferred as a combination of lots of small straight lines and ends up as a zigzag shape. So we have then carried out a study by using the IFC form, and it actually ends with a more stable and intersection curve due to a more stable definition and transformation of the data. Another challenge is related to the user record. Because we were using the BIM trap as a chat methodology for the report issuance, as the template is different among all the software, some of the configuration may be lost while exchanging via the BCF zip and become disorganized. So in the future, we hope that to further explore using the BCF XML or BCF API for better information mapping across the software. And in this project, we have been cooperating with over 25 project partners from local and abroad, and all of us possess high competency in our construction specialties. So with openBIM, it's not only facilitates smooth exchange of data between all the parties, it also allows us to have a better collaboration around the world, especially under COVID-19 for these few years. During the project cycle, we have implemented a lot of software with different objectives. openBIM allows us to select the right tools for the right task at the right time. And finally, we are confident to tell you that our openBIM strategy over the delivery process will certainly contribute for the future openBIM development, including the workflow. It also eventually brings us to witness the completion of the Henderson, a new landmark building in Hong Kong. And we believe that this project has opened a new chapter of openBIM and acts as a role model to guide the industry to use openBIM in Hong Kong. We have devoted many efforts for the over 5 years. Now it's time for us to share the experience and honors with everyone here. And that's the end of our presentation. Thank you very much, and we hope to see you again next year.
Thank you very much to the whole team. As the only finalists in the construction of the building category, we will now move straight to Q&A from the jury. So if you all want to come up, or some of you want to come up, I'll get your colleagues online.
We also have our online.
Perfect. Yeah, so we have some of the team online as well. So are there any questions from the jury?
It's really a wonderful project, and thank you for the presentation, very good presentation. I just want to understand a little better how you involved the supply chain, and so how they are really committed to openBIM, and for the Handover, it's a way to collect all the information about it.
Maybe let me maybe have a little bit elaboration in the capacity of a property developer. I just mentioned about in the construction stage, our main constructor has to take care not just the consultant, also the subcontractors and all the suppliers. But in fact, in Hong Kong, not all suppliers and not all contractors are ready for BIM. So they are responsible for some of those incapable supplier or subcontractor. They are going to build the models in the BIM. But of course, there are some others contractors already get the BIM capacity in their own company. So that will be more easy to be part of the supply chain. Of course, in the future operations, because we'll keep the live BIM model, all the building assets and information will be in the. I just mentioned about in the digital facility management portal, and the management process and also maintenance schedule, everything can be through the digital portal to approve all the operations. I hope I help answer.
So I think of the steel structure, because now the steel structure we are using the model for modeling the detail enough for fabrication, and they use the steel model to factory in the fabricated in the factory and transported to the site for installation. That's the part I think is related to supply chain.
From Hong Kong side, they have some supplement. Our Angela would like to explain further our subcontractor.
Yes, actually in our BIM model, we have all the unique ID contained in each element. So from this unique ID, which we can match with the factory progress, they will give Excel data to input all this status, whether it is already cutting in the factory or delivered to the site. So they update this information to the Excel data and then map this data to the BIM model. Then we can use the BIM model to display the status of the logistic.
You mean the status by color?
Yes, exactly. Yeah.
Hello, my name is Eric, and I work at Trimble, so it was very happy to see that you used Trimble. So you're of course then the obvious winner already. A couple of questions, if you can remember 2 questions. The first one is about the process. Did you use VDC, for instance, as the design process, virtual design and construction? Have you any thoughts around agile processes? And the second is about classification. When you have facility management, you must classify all the objects in the model. That's how I agree with. Have you already applied the classification system in the PIM model, or will you do that in the asset information model?
Let us answer the second question first. In the management for the handover process, we are actually liaising with our FM team, and it is quite early to do so because we still have more than about 1 year to the occupation permit period, and then we already gather with our FM team and the client team and the design and construction team together to find a way out to map the BIM object in construction stage into the extracted mode in FM stage. In our process right now, we just take the reference from the skill side. We try to extract the element ID or GUID, and then we gather the information through the IFC format, and then we try to get the information from the IFC format, and then we map the details through the we compile it. We are compiling a copy-like coding to map those data into the FM portal, and then after that, the FM portal can add whatever parameters they want, and then it can synchronize back into our native model. So maybe do you have any?
So in other words, we didn't utilize unit class, this kind of thing, or omni class to do the classification. We use Kobe to do the classification.
Yes, we use Kobe and the ID.
Maybe let me make a little bit supplement on the question 2 and then go back to question 1. We are not new to digital twin. Actually, back to 2014, we have our first digital twin. So we learned a lot of painful experience through the establishing of the digital twin. Your question is very important because in the construction stage, if there's no unified or how to say it, if we are not agreed the taxonomy and also the naming system, all the building assets will be very confusing in the FM portal. So at the beginning of this project, I mean this in the design stage, not in the construction stage. The first thing to do for the leading BIM consulting is we have to set up the whole naming system for all building components. Just for example, air handling unit. Usually in many schematic diagrams, they just mention ASU-1, ASU-2, and then all the floor are named in this way. But you can imagine what will happen in the BIM model and then carry forward to the FM portal. So we are aware of that. And because the model and the common data environment actually carry forward from the design stage to the construction stage. So they are actually right on the same platform, also same triple connect. And get all the collaboration. So, but of course, we are at the midway of the construction, and I have to say, I just mentioned many of those subcontractors and suppliers are not familiarized with that kind of system. So they have a heavy workload to support those contractors not ready for BIM. For the question 1 is RVDC. Yeah, maybe they have a better explanation.
With a virtual design construction, and we are parallel on our projects. Yeah. Actually, on the tenders, actually, we are also using the VDC, and on the construction, we use a lot for before construction. We simulate the process in triple connect, and we detect what is process, what will happen in the virtual environment first, and then solve it in the virtual environment. And apart of that, after that, we're also using the data serving in the single connect to record the experience. So they're all linked together to form a virtual to make those realistic things happening in the virtual environment.
Let me make a little bit supplement.
We have maybe just 30 seconds more for questions.
Oh,
We have
sorry,
two other
sorry.
presentations to go.
Okay, okay.
So just so people we'll say if there are any other questions.
Can I just make a kind of closing statement?
Sure, yeah.
Such an incredible initiative, and possibly not enough time anymore, but maybe we can later catch up. Just say really an amazing initiative, and what we would be interested in, what kind of challenges you came across from the perspective that you have to handle as well documentation, unstructured data, and structured data to really maintain the data for the FM processes later. And I guess there's a lot of knowledge around, but it's probably out of time to look into this. So thanks again, really congrats to this initiative.
If there is time at the end of the Q&A for the next category, we can always come back if there are more questions from the jury for these guys. Perfect. Thank you very much, everyone online. Okay, so now I would like to invite up Ms. Song for the BSI Information Delivery Specification for integrated openBIM and openGIS platform.
Well, I'm Min Song from SBI. SBI is a consulting firm from California. And our submission is about a machine-readable specification called IDS. IDS is a new standard, a very new standard from buildingSMART International. And we actually talked briefly about this on the first day with Mr. and sitting back there. And our submission is also about using this IDS to help the integration of openBIM and openGIS in government BIM data repository. And for today's presentation, we will go in this order. But before we start, Calvin Chan, founder of SBI, has prepared a brief introduction to the project.
Thank you, buildingSMART Awards Program, for giving our global project team this opportunity to present to you our submission under the Handover category. This submission is about one of the first to adopt the new buildingSMART Information Delivery Specification, IDS. This submission is about one of the largest adoptions of openBIM and IDS in an urban city scale. This submission is about the use of 8 sets of open standards to work in an ecosystem to ensure that it's about open standard driven, smarter city management. In fact, our project team has a track record over the 20 years, whether it may be working with the Finland government 20 years ago with Senate properties, or working with the GSA 18 years ago to adopt IFC and MBD, or in the last 2 years working with this project to work with the Hong Kong Lands Department. It's about pioneering openBIM applications, proving the value propositions. In our case, we are not only the first to adopt IDS, but we are also actively contributing to the development, to the feedback loop of IDS. It's about the largest adoption of openBIM and IDS, designing beyond a project, beyond one building, one infrastructure. It's about getting ready to get up to 300,000 project information models in the future. We are designing this infrastructure to be future bulletproof. At the same time, it's beyond just IFC and IDS. We are working with a total of 8 sets of open standards, including OGC, Open Geospatial Consortiums, City GML, so that we can work with these 8 sets of open standards to ensure that this ecosystem of open standards allow us to work with streamlining, with open urban information, and also open building and infrastructure information. At this time, let me pass it back to Dr. Min Song to go through the project detail.
Thank you, Calvin. So a little bit about the project background information here. Our client, the owner of the platform is Lands Department. It's a government agency in Hong Kong. and Architectural Services Department that has been also very supportive of this project as well. And like Calvin mentioned, one of the goals is to establish this government BIM data repository, which is to store the 300,000 models in the future. And we are from the US, and we also have 5 different teams from Europe, with us joining here today. And so it was a collaborative work between the teams from the US, Asia, and Europe. So, and it's also a large-scale project in terms of area. This is the area where the prototype of IDS Checker was deployed at. So within this white boundary area, there were new buildings, new roads, bridges being built. And that area is 1,500 acres. And within that area, we had initially 260 RC models coming from different works departments. But that's not the only models that we had. We had around 1,000 contextual models to give context in the GIS map. So if you kind of see the whole area of the screen right here, that's roughly around 8,000 acres. So going more into the openBIM information, with that first batch of 260 IFC models, what the government agency first did was they published BIM harmonization guideline. But the downside of this guideline is obviously it's a human readable document that computers cannot really understand. So with this written guideline, you cannot really precisely and digitally define your specification and check your models against that specifications. Also, there's this room for human error because people have to kind of understand the written guideline and implement them into a model checker piece of software, which maybe the result may be slightly different between different people. So that's when we kind of turn to machine readable specification IDS new standard established by buildingSMART in 2022, version 0.9 at this point. And the intention of this standard is to make machine readable specification interoperable between different stakeholders and BIM tools, so that you can generate a specification from one tool and export that to another tool and import it for model checking and other purposes as well. Because today we do have definitely machine readable specification. It's nothing new, but it is kind of living inside one piece of software that's not exported to other software. So next we have, I think, Nelson Nam from the Lands Department. He is going to explain a little bit more about the IDS project and the quantitative side of the IDS project.
One of the key challenges issues to the success of the BIM data repository is to maintain a consistent good quality of data among hundreds of project teams of government agencies per year in Hong Kong. Based on the international best practice in addressing current issue of data exchange of BIM data, Lands Department adopted the framework of Information Delivery Manual from BSI to develop the solution of Information Delivery Specification checklist. We applied the innovative suggestions on the use of quality result of IDS checking and work out a scoring matrix for project owners to aware quality standards. The scoring matrix at the beginning can be used as a baseline to encourage the project owners to carry out ongoing improvement of the data quality, aiming to support a common goal of data-driven decision for smart city applications in Hong Kong.
Thank you, Nelson. So this is an example of IDS XML file, obviously XML format, but we had 9 additional XML specifications written for the project. The downside was that IDS standard, it's not something that you could use for all kinds of checks. There are limitations. For instance, we cannot really do geometric type of checks. So for those part, Iri from Finland helped us with the tool that most of you probably know, the simple BIM. So in total, we had, I think, 23 checks, 23 specifications for this project. And the objective of this IDS, obviously, it's not for small scale projects. It's not for individual projects or building. It is aimed at handover at an urban scale of BIM data repository. One use case is 4D simulation at a city level, And for that type of high-level use case, you need information also on a high level, for instance, like facility types and construction start date and construction end date. So the ideas and specifications that we used or developed were kind of those ones that are applicable to multiple different types of categories in the industry. And this is the ideas checker that we developed after coming up with the XML format. It runs a check with the FC models, and here are some of the checks that we implemented. It has high-level check like the construction start date and construction end date. Georeferencing is also important because you have to automatically locate the building in the context of the map. And after this ideas checker was developed, we tested it with 149 IFC models. Building projects were tested, infrastructure projects were tested, and the maximum score that you could get for an IFC model was 300 points. And the average score of this 449 project was around 150 points. And the building projects scored higher compared to infrastructure projects, as you see here. That's mainly because today we do have a very good definition of IFC structure for building projects, but the infrastructure project is lacking a little behind. And also, we are hoping to see IFC 4.3 in the future, and when that comes out and software implements it, and if there is a export engine that successfully exports IFC 4.3, we expect the infrastructure project ideas scores to go up in the future. And then the time it took to check each of the models, it was also pretty quick. So it took around 20 seconds to 12 seconds actually to check each of the models. And even with a fairly large project like the one that you see on the left side, with 2,500 3D objects, it took around 10 seconds. And when you have a very large objects on the model with 100,000 3D objects, so it does take a longer time, but on average, it took maybe about 12 seconds. So stepping back a little bit here, kind of a 30,000-foot view of our architectural system. So the ideas checker using the open standard is here at the top, and the BIM data repository GPDR that I mentioned is this gray box here at the bottom. But it's not only the ideas checker that we use open standards for. We used total, like Calvin mentioned, 8 sets of open standards or solutions. And the CityGML was one, the openGIS format. And then GLTF for data streaming to simplify the geometry and make that extremely fast. That is also open format. And 3D tiles, that is also open format. And DCF was issued to communicate the check results with the authors. And then buildingSMART data dictionary, this is something that's not implemented or tested yet, but we plan to use this in the future when IDS standard can be mature enough to link the data from the PSVD. And so you can see that a lot of open standards were used, and this is possible because there is great support from the government agencies. And next, Christina Bloom from Architectural Services Department will explain government support for the open standards and implements.
The Architectural Services Department has always kept exploring new grants and innovative solutions. Sharing of data and information among works departments can facilitate better and more efficient works. The development of the government BIM is one of the key platforms for data exchange. To align with the Development Bureau's software neutral policy, open standard is promoted. Standardizing the requirements helps to ensure the quality of information exchange and facilitate reuse of data in the future. The IDS checkers provide an automatic solution to check BIM deliverables in a smart and efficient way.
Thank you, Christina. So, like Christina said, this is a pretty much open standard, and first objective was to store, BIM data in IFC format, open format, into this GPDR. But then the government agency wanted to go further from that building applications on top of government BIM data repository. So, for instance, applications that you see on the right side, the 4D simulation that I've mentioned, and also other applications that you see here. But today, I'll just focus on the 4D simulation at urban scale and how we came up with that using a set of open standard. So before developing this application, what we first did was identify the processes and information exchange between different stakeholders. And based on that, really think about the IFC entities, property types, and the values within the IFC model that's going to support the 4D simulation and openBIM and openGIS integration. Once we had that human-readable specification in place, then those were also used to author IFC guideline for Revit users, so that you can export IFC entities and properties and values correctly from the Revit tool. And IFC guideline was used by, obviously, the modelers to generate the information required for the 4D simulation. And the IDS in written format was converted into machine-readable format, IDS XML format, and then imported into IDS checker for checking IFC models. And if issues were found, then BCF was used to communicate those issues with the authors. And when the IFC model is in good shape, then the model was handed over to government BIM data repository, which used additional open formats and standards for streaming the data. And in the end, when the IFC models had all the required information items for 4D simulation, that was materialized into the 4D simulation application. So that is a typical workflow, but this is something that's applicable for other use cases that you see on the right side. This is the demo of the 4D simulation application. You see the coefficient metrics on the graphs on the left side, like the number of workers needed per area, number of jobs created per area, linking coefficient metrics with IFC slab, the area coming from IFC slab, and the total built area, and so on. So, in summary, the project, the IDS project, we used, like Kevin mentioned, a set of open standard, not only openBIM, but openGIS and other open formats for streaming data. And then we developed 10 machine-readable specifications based on the new buildingSMART IDS standard. Those were imported into IDS checker that we developed and used the IDS checker to check or test the 149 IFC models that we used. 47 were the building project and 102 were infrastructure project. And the time it took to check each of the models was pretty quick, 12 seconds. And so overall, the IDS project, the objective of this was to make the data repository really scalable, serviceable, and shareable, so that the handed over IFC models meet the requirements for the GDDR. And really, at the end, give the ownership of the data back to the client, the government agency, so that they can not only archive and see the details of the data, but use the data to develop applications needed from them. And also make this process really repeatable, meaning that if you have a GDDR that has 300,000 IFC models and are using proprietary APIs to build application, that would be very difficult. You might have different documents, SDKs for different types of software. But when you have IFC API and all the models are based on IFC, then that's the only IFC API that you have to study to build applications. In closing, so again, we are Lands Department and Architectural Services Department from Hong Kong, and SBI is from the US, and we are openBIM and openGIS experts from the US, Asia, and Europe, and this is the contact point. So myself and Rick Booster be around here. So if you have any questions after the presentation and training sessions, feel free to let us know. Thank you.
Yes, good morning, everyone. I'm going to present by sitting because when I'm standing, I don't remember to breathe. So Today, I'm going to present you our project, Handover to FM with openBIM. My name is David Betko, and I'm a BIM team coordinator in Moscow, Warszawa. Today, I have an opportunity to present the achievements of the joint works of the many people, especially from the construction side. On the slide, you can see also Wojciech Filmowicz, who is a site BIM engineer and done a lot of work to achieve the project goals. A few words about our company. Moscow Warszawa is a general contractor company. We are the oldest construction company in Poland, operating in the industry for over 77 years. We are one of the founding members of buildingSMART Poland, and as a member of buildingSMART, we paid attention for digital upskilling of construction workers and to avoid digital exclusion, especially these employees with many years of experience in our industry. We build the future is our company motto. Because of that, to achieve that, a few years ago we started focusing on openBIM as a base of our digital strategy. openBIM allows us to use simple tools adjusted to our needs, and we are able to scale up the use of openBIM and incorporate it into our everyday workflows. Our strategy is based on engaging employees to use BIM by responding to their needs and making it a part of their everyday tasks. Here you can see our project, Urząd Marszałkowski in Szczecin, built for a public client. It was design and build formula. It was divided into two stages. The first one was about deep renovation of existing building, and the second one is a new construction of passive building. Both of the buildings required sustainability certificates. And to fulfill clients' needs, openBIM was used to reach sustainability goals. By using the openBIM framework in the design and construction processes, all sustainability and energy performance was met. Client requirement was to prepare also a as-built model and develop and implement FM platform for the use. Enough of introduction and goals. Let's jump to the practice, to the construction site where all of the work is done. I would like to invite you to the Szczecin in Poland. As you may know, construction sites are generally conservative environments, following more traditional approaches of working. But over here we are pushing the boundaries by using openBIM to improve our way of working. And I will show you some method and digital tools that we use to achieve that. I need to mention, as a general contractor, we manage the BIM processes from the design to the until the handover stage and coordinate works of many multiple entities. In this case, more than 90 companies was involved in the project, including construction companies, designers, and suppliers. We also had more than 240 people involved in use of digital tools. From the very beginning, we had this idea that a finished product should be adjusted to the desired client needs, even if those needs was not well articulated. In this project, we realized to order to clients' expectation needs to be met, we need to extend the BIM usage above and beyond the basic requirements that client set up for us. Based on our aerial experience, we implement extra BIM uses, and in today's presentation, I will focus only on those required for proper handover. Here you can see the software map from the design stage to operational and maintenance stage. Importantly, each data submission was based on open formats like IFC and BCFs. And also we believe that construction workers don't need to use native files, this being reserved for designers and BIM specialists. For example, designers use tools like Revit, ArchiCAD, and the ECLA. There you can see this, hopefully. The construction workers, however, can easily work with IFC files, which contains the most important information for them. And here you can see some of the tools used during a handover phase. Yeah, so after the client did not require a mobilization phase, we took into account our previous experiences and decided to implement this. And during this, we provided proper trainings and instructions. We also described some of the processes. It was done for client, designers, and our subcontractors, and it allows us to clear the expectations and start work in a good environment. Yeah, so sorry for that. So the next thing is that we also prepared a federation strategy and set up coordination system for the models, and also prepared a implementation plan. We also defined modeling requirements and machine-readable information delivery specification, which was later used for model setup and quality control. Here you can see an example. We use internal classification in terms of preparation for FM platform. Also Uniclass, because client required this, and it includes also properties and all the properties that needed to be implemented. And here you can see how it was done. We used the Airtable platform, which is a database software, we can say something like that. So we prepared our database. Thanks to this, we could have information requirements always available and always up to date. And there you could see export to the PDF, and also it was prepared for XML export for the native software like ArchiCAD or BIM Collab for project. Okay, so now I would like to go over the biggest challenge that we take on our construction site, especially during construction handover phase. It's about correct data acquisition. While the general process is simple to say, design, build, and operate, in practice, it has been difficult to accomplish, especially during construction stage, where it's challenging to coordinate the works of on-site itself. But we developed some techniques to directly tackle this problem. And as I mentioned, we was responsible for the coordination of work from the design to the operate phase. Firstly, let's focus on design stage and design data handover, which is a part of handover through the whole process. The copy format helps us to properly structure the data in the models, and not only in the models, because we used this data also during construction sites, which I will show you later. Designers extracted information from the material cards and inserted the information directly into view models, and it was later used in a FM platform. From the beginning of the project, we also placed a strong emphasis on the quality assurance and control of design, BIM models, and data. We regularly perform quality controls checks in terms of information requirements and copy data. All issues were communicated using the VCF format by using the BIM Collab platform. And we managed to detect more than 800 clashes and resolve them virtually instead of on construction site. Next thing, on site we were using Deluxe platform with access to the documents, all the documentation on site. Because of that, we reduce the risk of working on outdated documentation and improve the access time to documentation to just a few seconds. And it was especially important, it was crucial here because the construction office was located 1 kilometer, more than 1 kilometer from the construction site. That's why we also bought bikes for the construction staff on this project. It's not a joke. And in one day, the project manager did more than 20 kilometers on bike. I haven't mentioned this before, but construction was done mostly during COVID, which in the case of construction is more problematic than, for example, online selling or software development and so on. So we also reduced the COVID impact because of implementing those kind of solutions. What we learned during the process, it is better to divide quality checks into sub-stages in order to bring crucial information to the site at the right moment. So it needs to be checked more often and in iterated process. And also copy should be treated not as a final deliverable, but as a format to start the project with. And our biggest challenge, construction data handover. Capturing data during construction is much more complex because there are many more people and many companies who each creates a small portion of the project data to be delivered. As I mentioned, we had more than 90 companies to coordinate, and rather than just handing over the information from the execution stage, we aim to properly understand the client objectives. We wanted the client be able to use the collected information and documentation from the very first day of operation. In order to deliver accurate as-built model, we implemented series of methods. First is as-built changes registered on daylooks that allows subcontractors to register any changes spotted on construction site, and it was for workers on a construction site. Also, we used 360 photos, fast laser scanning, and also BIM models, and we tested augmented reality on this site. And here you can see an example of use of the Daylux platform, where we had a digital copy form for data collection. A subcontractor could select location, as you can see, or BIM element, and take a photo of a serial number and send it to us. After this, we could combine those data and we use it in FM platform. Next thing is the use of 360 photos. It allows us to reduce time needed to capture reality and support as-built models verification. It was also used during coordination meetings and support decision makings a lot, especially, as I mentioned, during COVID. We also use these photos to progress tracking and purchases to the subcontractors. And okay, all of the photos, 360 photos, was available for all of the workers, and they could compare this with the IFC models directly in the CDA platform. We took photos at least every month, taking a total of over 5,600 photos in over 800 rooms. Next method is a laser scans and point clouds by using that kind of scanners, and this allows us to record changes, especially in complex areas such as boiler room. We communicate these changes to the designers and subcontractors in the online environment in Daylux by using PCS. And we didn't stop at this. During that project, we tested AR solutions like HoloLens. We believe in the future it will help with planning works and avoidance of mistakes instead of looking for changes on construction site. So to summarize, all of the tools, combining them with the IFC models and documentations, allows us to democratize access to the data. Every project participant can contribute without additional costs by working in openBIM environment and at the CDA platform. And this removes the BIM implementation roadblocks, especially for those one taking their first steps in a BIM methodology, including client and also other small businesses. So Handover was redefined from the single event to a process throughout the design, construction, and commissioning stage. And here you can see part of this was digital commissioning. We took the initiative and convinced the client to conduct the digital commissioning process instead of using papers and emails. The client could focus on inspections and quality control rather on bureaucracy. Each defect was clearly communicated with a proper location, also photos and description. It helped us to register and manage all the defects and forward them to our subcontractor. Okay. On the graph, you can see performance through the time. From my experience, the graph looks very good compared to the other construction sites because it showed collaboration between a subcontractor and general contractor. Orange one are the tasks assigned to the subcontractors, and when they answer to us and we close the issue, it's a green. So this line is showing you that was a communication during the construction, and also the subcontractor could use check all the issues in given room by using QR codes. To summarize this, digital commissioning allows us to efficiently manage the defects as well as to efficiently remove them. We communicate over 4,000 tasks, and one task is more than one issue. Yeah, this is it. And second and last thing, the client required design of and implementation of FM platform consisting of 4 modules: IM, CFM, CMMS, and EMS. So along with our partner, Promar, and the future facility manager and users, we design a platform. Close cooperation allows us to better understand the client's information requirements and improve the process of gathering the info from the subcontractors. Here you can see an example that the platform used data from as-built IFC models and additional sources, and they combined it to each model. Another module of platform is an energy management system. This allows the facility manager to get real-time data about energy use, critical equipment, works hours, and connect this information to a specific BIM elements, sensors, and also BMS, serving as a digital twin. The design, during a more than 40 meeting with more than 50 representatives of the client, we achieved the use of the FM platform from the very first day of operation. And the platform is already in use, and the client confirmed the task completion with officially signed references. Okay. Also, this is important. Develop new module of the platform with use of IFC models. Will be accessible to more than 100 organizations who's managing more than 2,500 buildings countrywide. And openBIM was essential to this project because it served as a basic for BIM implementation and data exchange. This entry, I think, is competitive not because of the above mentioned innovations, methods, and solutions that we implemented, but also because of the strong focus on the client. As a general contractor, we took full responsibility for leading and helping the client and subcontractors through all the stages in order to bring value and quality to the construction, building, and collecting data. We also wanted to share our knowledge, so we were on 4 faculties and 4 universities, including the local one in Szczecin. We also shared knowledge through the conferences and shared knowledge internally in our company, where we circulate the solution for more than 20 projects, active projects. Last but not least, we collaborate with software vendors to improve the solution and report bugs, and we also works in a buildingSMART Poland FM room to share our knowledge. During the project, we verified that openBIM can be used from a project start to its completion, and in order to achieve a critical acceptance of openBIM, we have to ensure that everyone in the process is engaged and learning, so they can use skills and knowledge on current and future projects. And we know that little this has wide effect in a net benefit for us and also for everyone. Thank you very much.
If we can invite everyone from the Handover finalists up to the front, and we'll take questions from the jury.
Impressive presentation, I must say, both of you. One question for you then. The obvious question, was it any advantages with IDS compared to MVD XML, or any disadvantages?
For the second question, disadvantage, IDS standard, it's not capable of checking or specifying complicated rules. So, for instance, if you have route checking or distance checking between different components of the building elements, that's difficult to do. It's not really about the geometry. It's just more about the property LODIs and the values within those properties. So we did see that limitation, but IDS fits better for our kind of project because it's just on a city level, and we don't really want to go on a detail level for checking like building codes and so on. So on a city level, it really fits well. The advantage about IDS is because IDS is kind of a fairly new standard. The software companies are starting to build modules for IDS right now. But when we do have those modules, for instance, Apple software, I believe, has already a module, and other software, we have those modules that imports IDS.XML file, then you can, for instance, as a client or owner, send specification out to different stakeholders that are using different types of software. And when we have a contract, today we write specification in a different language. But when you have that contract package and RFP, the technical specification also can be supplemented with IDS.XML. So that's kind of the idea that we were also thinking about.
Those are the questions we're going for you. Again, thank you for interesting presentation. I was just wondering how it works in your country. So it's a top-down approach, so the government decide, and then privates adapt to these things. Because thinking to my country, it will be possible such approach. So I am interested in if it was really top down, or if there was someone from the private industry that supported the government with this vision.
So I think mostly it's driven by government agencies, top-down in that sense, top-down landscape. But we also do see that government agencies and people working there getting inspirations from what the private sectors are doing. So, for instance, AI is kind of the hot topic today, and before they have any requirements or something that has to be implemented in the guideline, the government agencies in the guideline, they get inspirations from what the private sector is doing in terms of AI and what is required to enable that from a government's perspective. So it's both back and forth, getting ideas and some days discussing, but I think mostly it's top-down kind of flow in terms of enforcing the regulation and the private sector is following the requirements.
But in terms of percentage, how much you would say, which percentage of the private is really using openBIM?
I think it varies by continent. So versus Europe, no.
I mean in your practice.
This so I'll say openBIM maybe more than 50%. When you say the country, I meant Hong Kong.
Hong Kong, yes. I have a question for you. I have seen, was impressed for how many files you have managed and the version of files you have managed. In the traditional building industry, it was very complicated because you never knew which was the last version, and very trials were on this. And so we, in Italy, we were thinking to start with blockchain, at least to ensure that the final version is really not manipulated by anyone. So I just want to ask you if you thought about this issue or you don't see any issue.
I see the issue, but like project like this, design is built when design is mixing with the construction. It will be very hard to implement, especially because of the usage of documentation by subcontractors. So I think the solution that we implemented improve working on a current version of documents. Of course, we didn't avoid any of all of the issues, but for now we are focusing on implementing this on our construction sites. Maybe in the future, but for now.
Yeah, thank you again. It's really 3 amazing presentations, and it's going to be a hard job for us as a jury to find a winner out of this, particularly as there are 3 very different approaches. So we have like a total strong initiative from the whole production process that leads into the handover. We have a very technical approach that comes from the whole quality management and has really automated this. And then we have a real deep inside operations approach where really the operations purposes and the way to get there and to get on day one the FM system running, or which the incredible value proposition or has been achieved. So that's going to be a hard headache for us after you have left. So, but really to really congratulate you all 3 for those initiatives, because I believe we as buildingSMART International, and saying this as a board member, we gain incredible insights from you all. The feedback that you get on the applicability of the standards we are providing, or is of inevitable value for us. So just to mention this as well. And so I don't really have a particular question, but just to leave this in the room, or that we see that there is incredible process to really generate value on the operations and the owner side, and this now becomes tangible, particularly with really looking into the buildings and objects as an operating model that then can be activated as a digital twin in the direction of ESG, which is actually executed in the operations. And I think all of those 3 aspects play a vital role in this while setting it up, or because you have to have all the sensors and everything activated. but you have to have the quality management as seen by Min, or that you actually can get there, and you have to really need the deep insight of the understanding of the operations processes and the information needs there to really deliver this along the way. So really thank you again from my side.
Any more questions?
I think it's just 2 minutes left. So
Yeah, we have just 2 minutes left. So yeah. Okay, well, thank you very much to all of our presenters today. We'll close the session now. If I could ask the jury to remain in the room for deliberations, and we hope to see you all at more of the events throughout the week. Thank you.